So, moving forward, okay, on Thursday, okay, there's general questions, and those vocab terms are also going to be on part 1. And for instance, some of these questions that could be from this video, maybe we're Googling it, maybe, I don't know. Okay, so with that, does anyone remember when you look at column 4? They talked about this yesterday. Column 4 of the periodic table. What are your top 2 elements in column 4? Okay, one silicone, the other one is carbon. Now, they explained this in the video, and it would be correct. Which one of them reacts or can bond more readily with other compounds? Which of those 2 elements can bond more readily to other elements? Is it silicone or carbon? It's actually carbon. So what can you tell me, everything, just very simple, what's true about those 2 elements since they're in the same column? That is a very important aspect to know. They've got 4 valence electrons. So what that means, okay, so this has an atomic number of 6, and this one's 14. Notice they're 8 apart, which would make sense because once that outer energy level is filled or full or half full, that's what some of you individuals are illustrating when you're doing some of these configurations. You're switching the numbers around and you're showing a process called hybridization. You just don't realize you're doing that, okay? So we're teaching you this to do it in this manner, okay? Following your slide rule, okay? First energy level,
2.
Second energy level,
2. 2.
oops, all right. Those 2 numbers balance each other out now, correct? Okay, so carbon's in the second period, so it's got 2 energy levels. It's in the second column of the P block. That's where that 2 comes from. And then for that second period, it's in the 4th column. So that's how all those 3 numbers are interconnected. You can do the same thing with silicone. We got 2, 6. Okay, so this is in the 3rd period. So there's 3 energy levels. It's in the second column of the P block, but it's in the 4th column of that entire period. You can make those predictions if it's an S or P block element. Do not do that for D or F block elements. Okay? Then, how is the Bohr model different than that of the configuration?
The Bohr model does not look anything like it.
Okay? So if you wanted to take a shortcut, which you could, what do we have left over? 2s2, 2p2. All 3 of those numbers add up to 6. Here, you might want to use neon instead. Okay, so then we have 3s2 and then 3p2. All 3 of those numbers add up to 14, and that's what we're looking for. One of the aspects that they're trying to illustrate on this video is when you see that element of carbon, they're showing you that it has 4 valence electrons like this. That's where these come from, and that's what you're going to be dealing with next chapter. They discuss it in this chapter, but that's too much information. Bohr models, configurations, and electron dot diagrams. That's just one of the aspects we approach this curriculum in that manner. So these 4 dots, that's just illustrating these 4 valence electrons. You could say the same thing for silicone. Okay, it's got 4 valence electrons. It comes from those electrons in the outer energy level, whether it's S or whether it's P blocks. Okay, That makes sense. This bonds much, much easier than what silicone does. Okay? And that's very important when you start looking at large molecules called polymers. And how did they illustrate a polymer? They had these funny looking things. I don't know if I can draw it. They had a whole bunch of these. I'm trying to draw paper clips. Do you remember that from yesterday? So what they're doing is illustrating these polymers by showing the paper clips as a molecule of carbon. Silicone can't do that because it's a little too big and it's just not reactive enough. Carbon is, silicone is not. Now, last thing I want to show you is chances are this is going to show up on part 2. And people are going to say, I don't know how to do this. Well, okay. All right. So let's go ahead and pick a number between 3 and 9.
6.
I didn't do that very well.
7.
No. I'm sorry.
We need a bigger number.
Let's go with 8, 9, or 17.
17.
Okay? 17. Okay? So what is everything you can tell me about element number 17?
Protons are 17. Woo! Electrons are 17.
Okay? So if it's neutral, that's a big if it is neutral, what charges do these have?
Positive.
Okay? What do these have?
Negative.
Okay? It's neutral. So how many electrons would that be?
17.
Okay? And then how many neutrons does it have? Right? We're telling you that it's neutral. You would have to know that information. Because if you have a periodic table out, what does it refer to about chlorine? If it's not neutral, it probably only shows one type of charge. That periodic table is a little more detailed. It's a lot bigger. The most common charge for chlorine would be the one that's on top of the list of charges. But in your element box, what does it illustrate for chlorine's charge? Is it positive or negative? Okay, I'm looking at the same chart that you have. Look at element 17. Oh, it's got a whole bunch of them in there. Okay, but it forms a charge of -1. I was under presumption it didn't have all of them in there. I didn't believe it was that detailed. But we're going to say it's -1. Okay? So with that, if we're going to do the Bohr model for that, we know there's 17 in here. Let's show if it's neutral. I'm telling you, that's how you know. It's a neutral element. How many electrons should there be?
17.
Okay? How do we go further from here?
No, 2, 7. What? Oh, yeah, because we're already at, yeah. 69. Oh, then another 2. No. Wait.
Well, add these numbers together. What do we get? 17. So why are we saying 2 more or 8 or...
I had my mind on a different mindset.
Okay? Now, this element is neutral. So if this gains an electron, which it wants to do, okay, that illustrated that in that Hunting the Elements video, and they probably come across it here at some point. This can hold one more, and if we add the numbers and letters together, what do we get? 18. So in the nucleus, it's got 17 positive charges. You add together the letters and numbers, and what do we get?
18.
Oops. Not doing that correctly. What happens when you add those two numbers together? You get -1. It may ask you on part 2, illustrate chlorine, fluorine, bromine, any one of those as a -1 charge. That's how you would do that. Okay? Yes. Okay? So, if it's saying if it's -1, yes. The reason I say that is you can do that. What do you suppose you can do with that 2 and 5? Or that E and 5? You can do that as well. That still gives you 18, correct?
How do you know it's -1?
Okay.
Because that gets you to 17.
You got 17.
No, but how do you know, like, you're, like, right away?
You would have to, it would say something like this. Do the Bohr model for this element with a -1 charge. Okay. Like what type of number?
Like, -2 or something.
Okay. So if we're going to do a -2, that would be, let's say, oxygen. Okay. Okay, what is the atomic number for oxygen? Okay, so if we're going to do this element, oxygen, and we're going to say it's a -2 charge, we're telling you this is a -2 charge. Do the Bohr model for that. Okay, first energy level, how many? Second energy level. Okay. Add those together. How many numbers do we have out here? 10. Okay. So how many positive charges are in the nucleus? Okay. So how many electrons do we have out here? Okay. What happens when you add those two numbers together? Isn't that what we're looking for? Okay? All right. So, left outside and left middle. Do we understand that?
Yeah, sir. Fair enough.
Okay, middle. Do we understand that? Right side.
She didn't shake her head.
Okay? So, we're under the presumption that you understand. It can be just the opposite if it's positively charged. Okay? So what we mean by that is go ahead and pick 11 or 12. Yes. Okay? Yes, what? Yes. So if we're doing element number 12, okay, that is magnesium. It's got 12 and what? 24? Is that right? Okay, we're going to say it is a +2 charge. Now, what that means is, do your Bohr model. Okay, there was a third energy level, but it's empty. Okay, so inside the nucleus, how many positive charges are there? Inside the nucleus. How many numbers are on the outside here? How many?
69.
So you add them two numbers together, what do you get? Okay?
So
It can be
if it's positive, you just do 2 less.
2 less.
Negative.
If it's negative, you do 1 more.
Oh, 1.
Or 2 more, depending upon the charge. Okay? So, left outside and left middle. Do we understand that?
Can we do a negative one?
Okay?
One more.
Middle. Middle. Middle.
Middle.
Right side. Right side.
Shake your flame.
Okay? So you said you want to do another negative one.
Yeah.
Okay? Okay. We're limited on, you could say, element 7, element 16, or element 35. 30. Which one did I hear first?
35.
35. Okay. So what can you tell me everything about element 35? Okay, so there's 35 protons. Oh, we're talking about bromine here, aren't we? Okay. The atomic mass for bromine is what, 70?
79.
Okay, so 79. Okay. Now, we're doing a -1 charge now.
So it's negative 35.
Okay, so we're going to say this has a -1 charge. So that means, does it have one less electron or one more electron? Okay, so how many electrons is that?
36.
And how many neutrons does it have?
44.
Right? You take 5 from 9, gives you 4. Take 3 from 7, gives you 4. That's where that number came from. Okay? You can illustrate this now. We've got 35 protons in the nucleus because that's the atomic number. Okay? Follow your slide rule and the Bohr model. Okay? If it was neutral, that would be 5. But it's not neutral. So what makes more sense to you? Seeing 2 and 6 or 2, 5, and then that extra electron? Which do you like seeing better?
6.
Okay. So if you add all them numbers together, how many electrons are out here?
36.
Just what we're looking for, -1. Okay?
So if it's just -2, then you just do 2 more.
Then it'd be 2 more electrons then. Yes. Now,
On the test, will you show us how many?
you would have to know that. It tells you that right here. Okay? Okay, so I'm under the presumption that left outside and left middle understands this.
Yeah, I understand it a lot. 100%, Mr.
Okay? Middle. You're shaking your head yes. You tell me you understand. Right side. Okay.
Just because I know today doesn't mean I'll know tomorrow, though.
Well,
That's why we're reviewing tomorrow.
Wait, are these going to be on the exam?
Yeah.
possibly yes. Those who choose to do what we ask, others who choose not to. Yes. Okay. So moving forward in that video, that's all I have. We'll catch up to you next time.